In this video lesson, we're going to have a look at diseases of undernutrition, which occur when there are dietary deficiencies. As you can see from the table, there are a large number of possible diseases of undernutrition, from anemia, osteoporosis, diverticular disease, goiter, xerophthalmia, marasmus, kwashiorkor, beriberi, and pellagra. In this lesson, we're going to focus on the top three: anemia, osteoporosis, and diverticular disease, as they have the most relevance in Australia. The remaining diseases will be studied later in this course in the topic of global nutrition. You can also see that these diseases of undernutrition all relate to dietary risk factors. Specifically, anemia relates to a deficiency in iron, but it could also be folate or vitamin B12. Osteoporosis arises due to a deficiency in calcium, which can also be related to vitamin D, and diverticular disease is strongly correlated to a deficiency of fibre in the diet. We'll start with anemia, the most common nutrient deficiency in the world, affecting more than 1 billion people on the planet. Anemia results from a deficiency of iron, folate, or B12, as mentioned. In the image at the bottom of the screen, you can see normal red blood cells under the microscope that are plump and full, and there are many of them, compared to the anemic red blood cells in the left image, where there are fewer red blood cells, they're less plump, less red, and generally don't look as healthy. So if anemia results from primarily a deficiency in iron, what does iron do? Iron is needed to make new red blood cells. It forms part of the hemoglobin protein, which carries oxygen around in our bloodstream to all of the cells in the body. As you can see in the image, iron forms the binding site in the hemoglobin molecule, where oxygen joins into the molecule for transport around the body. Without iron, we won't have effective hemoglobin, and therefore we won't have effective transport of oxygen in our bodies. So, why is iron important? The brain has a high demand for oxygen, and additionally, iron maintains energy release required for aerobic activities. Low iron levels reduce hemoglobin production and the transfer of oxygen to cells, as mentioned. Here is an alternative representation of normal red blood cells, this time on the left, compared to anemic red blood cells on the right. If you have another opportunity to see the difference in the size, the fullness, the colour of the two types of cells. So when anemia occurs and hemoglobin production is reduced, what actually happens in the body? The symptoms of iron deficiency primarily relate to tiredness or lack of energy, as our cells have a reduced access to oxygen. This leads on to a reduced capacity for exercise, particularly endurance exercise, as well as everyday work. It can lead to a loss of appetite, a lack of motivation, inattention, paleness, and weakness of the muscles. It's worth noting here that anemia can also be caused by folate deficiency, in which case large, oval-shaped, immature red blood cells form. This is in contrast to the smaller red blood cells that form in iron deficiency anemia. However, the net effect is quite similar in that folate deficiency anemic cells cannot carry oxygen through the capillaries as efficiently as normal red blood cells. This deficiency is not particularly common in Australia, so we'll retain our focus on iron deficiency anemia. Let's look at the risk factors now. It's important to know that women are much more prone to iron deficiency than men are, and this is mainly due to their menstruation cycle. Women can lose anywhere between 30 to 125 milligrams of iron in blood every 28 days. Obviously, this iron that is lost needs to be replenished, and the main way that we do that is through our dietary intake. Pregnant and breastfeeding women are at a greater risk of developing anemia because their iron needs are higher at this time of life. Iron is prioritised for either the growing fetus or their infant child if they are breastfeeding. This leads on to newborn babies also being more likely to suffer from iron deficiency if their mother was deficient during pregnancy. Other risk factors include a vegetarian or vegan lifestyle, as people who consume a plant-based diet only consume non-heme iron, which is less well absorbed by the body than heme iron found in animal foods. Children going through puberty also are at greater risk of developing anemia, mostly due to it being a rapid growth phase in which their blood volume increases quite significantly. Obviously, a greater blood volume requires a larger number of red blood cells, a larger number of hemoglobin molecules, which all lead to an increased demand for iron. The last risk factor is for athletes involved in high-intensity training or bulking, in which, again, an increase in the number of red blood cells is required to meet their activity level needs. If we put all of these risk factors together and find that some are overlapping, certain groups of people become at either high risk or extreme risk of developing iron deficiency anemia. We can group risk factors largely as demography, which is about where you live, what community you come from, so the elderly, teenagers, females, immigrants, Aborigines and widowers are all at a greater risk already. If we then couple that with some dietary risk factors such as a low iron diet, as may be found in vegetarians or vegans, low vitamin C intake, excess tea and coffee, fad diets, etc., as we'll cover in a moment, you can see that we could increase the risk to a high level. If demography and dietary risk factors were put together with social risk factors as well, such as alcohol abuse, depression, poor eating habits, you could end up in the situation of having an extreme risk of iron deficiency anemia. In order to be able to prevent the development of iron deficiency anemia, it's important to understand about the absorption of iron from food. Heme iron found in meat and animal products is most readily absorbed by the body. In contrast, non-heme iron from plant foods is less readily absorbed. It's also good to know that the absorption rate of iron increases when consumed with foods rich in vitamin C. Such foods include citrus fruits, broccoli, cauliflower, pumpkin, and cabbage, which are all obviously foods that could be consumed by vegetarians and vegans, for example, to increase the amount of iron they can absorb from their plant-based diet. Another strategy, which this time would not be acceptable for vegetarians or vegans, is to add a small quantity of meat or fish to improve the bioavailability or the absorption rate of iron found in low-cost staple food sources, such as rice and soya beans. This is a strategy that's been used for centuries in the poorer cultures of the world. Foods such as fried rice, with a very token amount of bacon, pasta carbonara, again with a small amount of bacon, and many Asian noodle dishes combine the iron found in grains and beans with a small amount of animal or heme iron to increase the bioavailability. Not all foods, however, are good for iron absorption. There are certain foods which actually reduce absorption. For example, cellulose and phytic acid found in whole grain cereals can reduce the absorption of iron from plant-based foods. So for example, if you had a diet high in unprocessed bran, you could well run the risk of iron deficiency anemia. Additionally, large amounts of tea or coffee in the diet limit iron absorption.